Hey, what's up YouTube? Mr. Fackenthal here, and today I'm going to be teaching you how to solve special systems of linear equations. So, there are three types of solutions that a system of equations could have. They are one solution, which is what we've been working with so far since 5.1, 5.2, 5.3. It's your basic two lines on a graph, they intersect, and you get an ordered pair as your answer. No solution. These lines are parallel. Two lines that are parallel on a graph. They have the same slope but different y-intercepts. So think about it. Two parallel lines on a graph. They're going to go on and on and on forever, but they're never going to intersect. So there won't be a solution. At no point are these two lines equal. There will never be an ordered pair. And our third option is infinitely many solutions. These lines are the same. If we had two lines graphed on a coordinate plane, and both of them were exactly the same line, at any point on that line, we would have a solution. Remember, a line is just a infinite amount of points put together in a line. Okay? So each one of these little points would be a solution. So take a minute, copy the key idea down, and then we're going to move on to example 1. So, example 1. Solving a system. First, we're going to start with no solution. There are two methods to solving a system with no solution. Method 1 is to solve by graphing. So, they gave us the system y equals 3x plus 1 and y equals 3x minus 3. So let's just start by graphing these two solutions, graphing these systems. So we'll start equation 1, we'll make this the blue line. Put a little dot here so you know. Our y-intercept is 1, and our slope is 3. So we're going to go up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. Alright, so I'll plot 4 points. I think I have a line tool that I could use. Let's see, can I change the color? Yes, I can. Let's see how this line tool works now. Alright, so we'll start here. Use our line tool. And make sure we cross all 4 points as best we can. Extend the line. And there we go. So that's our first line. That's equation 1 we graphed. Next, we're going to graph equation 2. Equation 2 says 3x minus is y equals 3x minus 3. So we'll start at negative 3, 1, 2, 3. And we're going to go up 3, 1, 2, 3, over 1. We're going to rise 1, 2, 3, over 1. 1, 2, 3, over 1. Put a little red dot here so you know that that's equation 2. And we'll go back to our line tool. We'll start, I need one more point, I'm sorry. One more point, 1, 2, 3, over 1. Okay, now, line tool, connect the dots, let's see, right about there. Alright, so now we can see that, hang on, sorry guys. Okay? Now, we can see these two lines are parallel. They do not intersect. So, when we have the same slope, but different, I'll just write DIFF for different, y-intercepts, then we have no solution. Because these two lines will never intersect. There will never be an ordered pair on these lines where the two lines are equal. Now, there is another method to solving a no solution system. We don't always have to graph. We can use one of our other methods of solving systems. So, let's solve this system by substitution. First, we got to realize both of these are solved for the variable y. Y equals 3x plus 1 and y equals 3x minus 3. So since they're both set equal to y, we could set these equations, this half of the equation, equal to each other. So that'll give us 3x plus 1 is equal to 3x minus 3. Now let's solve for x. So the first thing we have to do to solve for x is get all the x's on one side and everything else on the other side of the equal sign. Subtract 3x from both sides. Subtract 3x from both sides. Now when we do this, 3x minus 3x is equal to 0. Bring down the plus 1, which is equal to 0 minus 3. So 0 plus 1 is 1, and 0 minus 3 is negative 3. Now when looking at this, we know that 1 is not equal to negative 3. So since it's not equal to negative 3, we know that that is not a true statement. Therefore, there is no solution. Alright, so when you get an untrue expression, we can say that there is no solution. Let's move on. Take your time copying that down. Now we're going to move on to example 2. Example 2 in the notes. Example 2 is going to give us a word problem. We're going to solve this system, and it's, as you can guess by the title, we're going to have infinitely many solutions. So the perimeter of rectangle A over here is 36 units. The perimeter is 36 units, and they gave us that the length is 2x and the width is 4y. The perimeter of rectangle B over here is 108 units. We have to write and solve a system of linear equations to find the values of x and y. So we want to find out what x is and what y is. So the first thing we have to do is write our system of equations. We know that two opposite sides of a rectangle are equal, right? So 2x, that side will be 2x, and this side will be equal to 4y. We know this side is also 6x, and this side is also 12y. So we know that the perimeter is length, that's L plus L plus W plus W equals P. So L plus L is going to be equal to 2L plus 2W equals P. Now let's plug in our length and our width. 2L is going to be 2. Our length is 2x. Plus 2, our length is 4y. And our perimeter for rectangle A is 36. We got that from the problem up here. Now let's simplify that. 2 times 2x is 4x, plus 2 times 4y is 8y, and that is all equal to 36. So this is our first equation in our system of equations. But we know we need two equations to have a system, right? So let's find the perimeter of rectangle B. Rectangle B, we know L plus W plus W is equal to our perimeter. So our length plus our length plus our width equals the perimeter. It's all four sides added up. We can simplify this to 2L plus 2W equals P. So now let's plug in our length and our width. 2 we have our length is 6x plus 2 times, whoa, I gotta stop, what, hang on, 2 times 12y equals and our perimeter is 108. 2 times 6x is 12x plus 2 times 12y is 24y, and that is equal to 108. Okay, now we've set up our system, and we know that this is our second equation over here. Now that we have our two equations for our system, we can go ahead and solve it. Alright, now that we have our system of equations, which is 4x plus 8y equals 36, and 12x plus 24y equals 108, we can go ahead and solve using method 1, which is to solve by graphing. I went ahead and graphed these two equations for you ahead of time. Now, you'll notice we only have one line, but this is actually both lines. They are overlaying each other. Okay? One is right on top of the other. So both lines are exactly the same. They have the same y-intercept, which looks like it's at about 4.5, and they have the same slope. Now, we remember a line is just made up of infinitely many points. Therefore, any point on this line, any ordered pair that we would get from this line, would be a solution to the system of equations. So the lines that have the same slope and the same y-intercept, so the lines are the same. This means that they will have infinitely many solutions. Any ordered pair that we took from these lines would be an answer to our system. It would work out. Now let's try method 2 of solving this. Method 2 of solving this system of equations would be to solve by elimination, the new method that we learned in 5.3. So to solve by elimination, we have to multiply equation 1 by 3. So we have 4x plus 8y equals 36. If we multiply this by 3, use our distributive property, we will get 12x plus 8. I'm sorry. Whoop. See, it's easy to make mistakes. 3 times 8 will give us 24y, and 3 times 36 is 108. So, after we distribute that, we have 12x plus 24y equals 108. Now, let's multiply. After we multiply equation 1 by 3, we have to subtract the equations. So our new equation 1 goes up here. 12x plus 24y equals 108. And equation 2 is, sorry, I'm still getting used to writing on this. 12x plus 24y equals 108. So let's go ahead. First step in elimination is to subtract. So 12x minus 12x equals 0. 24y plus 24y equals 0. And 108 minus 108 equals 0. So 0 plus 0 equals 0. Therefore, we have infinitely many solutions. Okay? Any number that we plug in for x and y would be canceled out when we subtract, therefore infinitely many solutions. Alright, thanks a lot for checking out my channel. Like and subscribe, comment below, let me know what you think. Can't wait to see you back for the next lesson.